This is a book that you can use to learn differential equations. So if you want to learn differential equations, you have to learn calculus first. So once you know calculus and you know like how to integrate and stuff like that, then I think you can start learning differential equations. But until then, it's not really something that you really can do successfully. So that is the main prereq to a subject like this. Now this book itself is a textbook. This is the book that I used when I studied differential equations for the very first time. And is it the best book? I don't know. I don't think it's the best book. I think it's a book. It's hard to say what the best book on differential equations is, especially when you're comparing textbooks. I have several, and they're all pretty similar. They each have kind of like their pros and their cons. I don't think I can definitively say like this is the best one. So here's the introduction. It starts with like the basic stuff, like the terminology, stuff you would typically see like the first day of class in a college level differential equations course. So I've taught differential equations in college, but I haven't taught using this book. I've used another book to teach differential equations in college, which is smaller than this one and actually a little bit easier. Some of the examples in this book are a little bit more intense, I think, than the book that I've taught from. Also, this is a bigger book. This book has extended sections. I don't know if you saw the cover there. It said boundary value problem, so it's got extra sections in it. There's a regular version of this book as well that doesn't have the boundary value problems. Okay, I want to emphasize that. So I'll leave a link in the description to this book or the one without the boundary value problems, whichever one seems to be more accessible. This one might not be so easy to find. Linear second order equations, this is really easy. All the stuff you cover in a differential equations 1 course in college, or I guess in high school if they teach it in high school. I'm not sure if they do. This stuff here, these applications, you may or may not do depending on the book, depending on the course, depending on the teacher. You know, those are topics that, you usually don't cover all the applications. You just cover some of them. You spend a lot of time focusing on like how to solve differential equations. Like this takes a long time here, this type of procedure. Laplace transforms, this is something that comes up a lot. I know in like in electrical engineering you see this a lot, Laplace transforms. And engineers study a lot of Laplace transforms actually. I had friends who were electrical engineers and they did more stuff with Laplace transforms than I did as a math major. So it just goes to show how deep mathematics is. You can study mathematics and still not know everything. Series solutions of differential equations. This takes a really long time. Actually, I have a few videos here on the channel of me solving these, and the reason I don't have more is because they're so hard to make. Your hand starts to hurt. I mean, the problems are 20, 30 minutes long, and I'm writing really small because it's really messy. Here you go, partial differential equations. This is actually a good book to learn partial differential equations. Like if you want to get started with those and you already know DE, this is good because it has a very gentle introduction because it's like part of a DE book, so they toned it down. It's not like it's an entire book on PDEs. No, it's just that's this book's introduction based on, if you made it that far in the book, you're kind of used to the book, you're kind of used to how it works. This one has answers to the odd-numbered problems, and they do have a student solutions manual, which I actually own. I have it somewhere, and it has like the worked-out solutions, which I think are pretty good. The exercises in this book, they're okay. I actually wouldn't say they're super hard. I would say they're about average compared to other DE books, about the same. Nothing spectacular, like really difficult or anything. Now the examples in this book I think are really good, and I think they're more intense than examples in other DE books. So I do think that this book has really good examples. I mean, here's one here. This is a great example. Looks like we got to find the inverse Laplace transform of this rational function. So a rational function of S, right? So they're using partial fraction decomposition. That's what they do there. So they find the coefficients A, B, and C. That's what all that work is, okay? And then once you have that, you can apply the linearity property of the inverse Laplace and take the Laplace transform of each piece, right? So, and then you just use formulas. Right? You just use formulas over here. And there's the answer. There's the answer. It's pretty cool, right? So, yeah, they had to do a shift here, which they kind of skipped the step there. With the shift, there is a shift you can do. You can show more steps. So that's something that I would do in a video that's not in the book or in a classroom. So it is a textbook. There are going to be steps missing. So I mean, it's a pretty easy step to skip. But if you're trying to use this for self-study and you see that step missing, it's like, oh no, how do I get better at this? So that's That's the hardest thing with books. I know I talk a lot about like, books are great and they're the best way to learn, but this is a clear example of a situation where a small step was skipped, which could cause, I think that step would cause a lot of confusion for someone because, I know that that's something that confuses people. And yeah, so books always do that. And I don't think they're doing it on purpose. I think it's just, the author has to make a choice. What steps do they show? Do they show all of them? Sometimes when you show all the steps, it's even harder. So I think what they do is they try to show what steps they consider the most important. And sometimes there'll be a step missing that would be kind of nice to have, and that's just typically how it works. So here they're solving for y of s. They're basically solving a differential equation, an initial value problem, using Laplace transforms. Yeah, there it is, solve the initial value problem. There you have, these are called initial conditions. And basically you take the Laplace of both sides of the differential equation, right? And then you let y be equal to the Laplace of little y, so big Y. So what you do then is you solve for big Y of s. And then this is the Laplace of your function. So the Laplace of your function, this is the Laplace of the answer, right? Because the answer, the solution to the differential equation is the unknown function, right? So you're taking the Laplace of your solution, basically, and setting it equal to this rational function. You might say, how did you get that? Well, you just took the Laplace of both sides. The Laplace is linear, so that means that, let me just zoom in here so you can see, when you take the Laplace of this entire equation, you can take the Laplace of each piece, right? All right, so you have the Laplace of this function, right? That's your function. That's the answer. The answer is y. So if you can find y, you're done. So we're at this point here, right? So if the Laplace takes your function and sends it to this, then the inverse Laplace will take this and send it back to your function. So basically, use the properties of inverses, or you can just take the inverse of both sides. They skip all the, they didn't say any of that here. I mean, they might talk about it, but they don't really show the work. So you could show extra steps here, again, to make this a little bit easier. So again, another con, right? So cons of textbooks, and you're going to find that with any book. I remember learning calculus and using the Stewart book, which is probably the most popular book in the world for calculus. I mean, it's super famous, Calculus by James Stewart. And there's places in the book where, the steps are missing or you just don't get it. And I don't know, I think it's just, it's normal, it's going to happen. That's why I think it's good to have lots of books, because sometimes certain books will have certain steps that other books don't have. Here's some properties of the Laplace transform. Cool. Yeah, this is the shifting theorem. Yeah, translation in S. Yep. Oh, the Laplace transform of the derivative. Yep, that's useful too. And some more properties here of Laplace transforms. Cool. Good stuff. Good stuff. I actually have differential equations courses that you could buy, actually. Check them out. They're on my website, mathsorcerer.com. And then just look for the one that says differential equations. They're actually on Udemy, but if you get them, please use the links through my website because it helps me greatly. Also, I lowered the price on Udemy so that if you use my links, I'm pretty sure you'll always get a low price. I'm pretty sure because I set the price at the minimum for every single course. And I have two differential equations courses. One has like longer lectures and one has like shorter lectures. They're both good. They're both different. You'll get some overlap on the material, but that's probably good. The lectures one has long videos, right? So that's the bad thing, or it can be a good thing. And then the other one has short videos. So yeah. Yeah, if you found any value in this content, feel free to hit subscribe. Oh, and check out my other channel, The Fitness Sorcerer. But yeah, if you take away anything from this video, it should be that this is a really good textbook on differential equations. You can use it to learn partial differential equations. In order to access this book, though, you do need calculus, right? So at the level of calculus 2, you want to know how to integrate because it will make it very difficult if you don't. So yeah, but yeah, it's awesome. Until next time, keep doing mathematics.